Yeah, so question number 1, section A saying, consider the following regression results of the impact of interest rates on Zambia's GDP. So which means GDP is the dependent variable, right? Your dependent variable is GDP, beta naught plus beta 1, which is interest rate this time around. And your X1 is interest rate. You're following, right? So your Y is GDP. It is being impacted by interest rate, yeah? She's your beta 1, all right? And on my, sorry?
Beta 1, this is 74%.
I don't know. The voice is not clear.
Okay, no, I was trying to write so that I know the solutions, which question, which paper they are coming from.
Yeah. So the one that is being impacted is the dependent variable. It's the one that is being influenced, So the Y variable is the one. And this one is your B naught, your coefficients. Sorry, this is your constant, your slope, right? This is your slope. And this is the coefficient.
Okay.
So you have the intercept. This one is, for example, the y-intercept. This is the slope coefficient. This is the intercept.
The
Yeah.
x-intercept.
So this is the intercept of the variable. Let's just say the variable, because this time around, this is just a variable. It can be any variable, and in our case, it is interest rates. So interest rates are represented by X. They're the ones influencing what? Y, this side. The standard error is given for both, the T statistics for both, and the P values for both. All right.
Oh.
And also there is the F for the entire model and the R squared. So is yeah. So what is the question really saying? Maybe we go straight to the question. What is the difference between the two regressions? What is the difference between two regressions? Number 1, what do you think would be the difference? The first one, what could be the difference?
The first one is y is dependent on x, is it? Or x is dependent on y. I don't know.
No, y is the one depending on x. You get it, eh? Yeah. Then what is the other thing? Okay. So number 1, I don't have to be rewriting these same things again that I already written. If you check, let's start with the the intercept. All right. Model 1 has an intercept. This one is an intercepted. There is no intercept here. You've seen, eh? It's just y is equal to beta 1x. Because the beta naught is now 0, right? It's y is equal to beta naught plus beta 1. This is the general, right? This is 1. 1 follows this one, but 2 follows this one. So it doesn't have the intercept. Okay? Did you get that one?
Yes.
There is no fixed intercept for it. That's the first difference. I don't know if you picked that one.
Yes, there's no fixed, there's no fixed, there's no intercept for model 2, right?
Then again, you could also explain again in terms of model validity. Model 1 is not statistically significant. Why? Because the p-value is greater than 0.05. This p-value. This is the metric that helps us to measure how the entire model, is specified. If it is correctly specified, and it really captures properly all the variations in the dependent variable, you find that the p-value will be less than 0.05. You get that one, right? Hello?
Hello? Yes, I'm getting it.
Mm-hmm. So that is with the model 1. So model 1, number 1, is not correctly specified, and it is not statistically significant as a model. It's not a good model. Okay?
Specified and
It's not a good model. Why? Because the p-value, you write this number, the p-value is greater than 0.05. Because the null hypothesis says that the p-value should be less than 0.05. It says that the model is correctly specified. That's a null hypothesis for this model. But since this number is greater than 0.05, we reject the null, which simply means that the model is not correctly specified. You got it?
mm,
Yeah.
mm. You said the model is better than 0.05
No, the
or
p-value.
for the
The
p-value.
p-value, yes, this p-value is
Okay.
the one that you use to measure model coefficients. Yeah.
Okay.
The model is not correctly specified. You get that one, right?
Mhm.
Those are differences, right? But when you check for model 2, you've seen for model 2 is 0, which is less than 0.05. Model 2 is correctly specified. You've gotten
Okay.
it, right? You see, this is exactly 0, which is actually less than that. Okay?
Mhm.
Another difference that you can mention is in terms of the coefficient of determination, right? The measures that are there. The R squared. Remember, the R squared is the coefficient of determination. It measures the proportion of the variations in the dependent variable explained by the model. That's what the R squared measures, right?
Mhm.
I sound as if I speak very fast. It
So,
measures the percentage or proportion of what? Of variations in the dependent variable. And our dependent variable is GDP this time around, that are explained. Explained by what? By the independent variable. What is the independent variable?
yeah.
Interest rate. This is what this measures. So after writing like this, we know that for model 1, only
Mhm.
44%, you multiply that R squared by 100, 44% is explained. Only 44% is actually explained by the model, right?
Mhm.
But when you go to model 2, how many percentages? About 74%.
74.
74% of variations in GDP are explained by interest rates in Model 2, which simply means that Model 2 has got a stronger explanatory power, right? It has got a stronger explanatory power as compared to Model 1. So Model 2 is reliable because you don't want a model that can't explain the variations in the dependent variable. You know, if anything, a model should be able to explain 100%, but it is not practical. It's not there in real life. There is no model that can explain 100% of variations. Because of that, the higher the R squared, the better the model is. At least if it can explain me above 80% or whatever, or 70% at least. But this one explains only 44%, less than half, which means you can't go for it. You got it?
Mm-hmm. Yes.
So in conclusion on part one, there are 3 points that you could write. Number one, in terms of intercepts. The first one has an intercept, the second one. Then 2, in terms of p-values, model significance, specification of the model.
Mm-hmm.
Model 2 is correctly specified. The p-value is less than 0.05. Model 1 is not specified correctly. The p-value is greater than 0.05. And then you can explain in terms of coefficient of determination, where you say the coefficient of determination for 2 is 74%, for 1 is 44%. You got it?
Mm-hmm.
Very good.
Mm-hmm.
Now, given the preceding results, these results, would you retain the intercept term in the first model? Explain your answer. Have you seen that we ran the model at first, it had an intercept, then it was like this, it was a bad model. You've seen it, eh? Then we had to rerun the model and it dropped the intercept. Then the results you've seen, they improved and the explanatory power improved. So the question is that, given the result, would you keep the intercept in the first model? You explain your answer.
In
5
the
if 3
first
months.
model, in the first model, no.
Yes, why?
Just like you explained that the coefficient of determination is 44%.
Mm-hmm.
Mm,
Yeah. So
meaning
when you drop the
it should have.
intercept, the model improves both in terms of the fitness, because this one measures, the R squared measures the model fitness. So it improves in terms of the fitness and also in terms of its explanatory power and also in terms of specification. You get it, eh?
Mm-hmm.
When you just drop the coefficients. This is what has happened in the second model. So when you drop the intercept, the model improves in terms of what? You
So
know,
in terms of dropping, is it?
in
I'm
terms of
confused.
the what's this, the
Dropping.
fitness,
How do you know?
yeah, in terms of specification and also in terms of explanatory power.
Okay.
Mbese sir?
Why?
How would you interpret now the slope coefficient in the 2 models? Number one, this one, we start with the first model. This one simply means an increase in interest rates, the dependent variable,
Okay.
the independent variable, an increase, a unit increase in what? In interest rates, which is our X. I'll just put X. You should put the real word is interest, not X. So a unit increase in X increases, because this coefficient is positive. That's why I'm saying it increases. Increases y. What is y? GDPI by 0.75815 units. Is that clear? That's the interpretation. So a unit increase in what? In interest rates. When interest rates change, or a unit change, you can just say change. If you don't want to write again decrease, to be general, you can just say a unit change in interest rates increases GDP or changes GDP by chan units. But since this is a positive change, so you just say it increases GDP. So that's an increase. You have understood, eh? That's the interpretation. Okay? Then, even this one is still the same stuff. I think we have already explained. So, a unit increase in X, which is the interest rate, increases Y, which is GDP, by 0.76214 units. Okay? Yes. So that's that. You already know this. What is the theory that is underlining the dropping of the coefficient? I've forgotten. I don't know. I need to go back. Yeah. The t values of the slope coefficient in the zero intercept model is about 2.95. Yeah. Whereas that with the intercept present is what? It's about 2 point what? 2.81. You've seen, eh? The t value of the intercept, this t value is this and also this. So seeing the t values are different, right? Can you rationalize this? The rationalization is still the same. Why? Because the significance is increasing, all right? When we drop the coefficients, that's why even the t value increases like that. Remember, the t value works like the p value as well, all right? The t value works like the p value.
So in fact, question, they would just tell you to interpret, not
Yes,
calculations. Okay.
yes.
All right.
I understand, eh? Hello?
Yes, sir.
Hello? Did you pick this one? Did you pick it? Did you get it?
No, this one. We are writing this tomorrow.
Yes, I'm saying, did you have you gotten it?
Yes, I've gotten like they're supposed to just interpret the information that you're given, and I've written some points.
Okay. We can cross over. Right. We go to question 2, right? The Ministry of Agriculture conducted research on the factors influencing maize. Okay. What is being influenced?
Maize.
Maize output. That is your Y. So your Y is what? Maize output. It is influenced by what? Those are X's now. X1. A multiple regression results related to this was what? Maize. Was capital, right? That was capital. The following, eh?
Yes.
Labor was influencing. There was seed quantity. There was what? Fertilizer. There was gender. And what else? 6 variables. Education, right?
Mhm.
So the regression results were given like this in the statistical package for social sciences. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, right? Plus beta 4 x4 plus beta 5 x5 and what? Beta 6 x6 plus the error term. This is the model. Actually, I've already answered the standard. This is the standard model for my. So what to do when you're standardizing, you just say let x1 equal capital like this so that you can easily standardize. Let x1 equal capital, x2 equal to labor, chan equal seed quantity, these variables. Then you write them like this. This is the standard form of the model. You have gotten it, eh?
Yes.
I don't know if I'm too fast.
No, it's fine. I'll even listen to tomorrow
Yeah,
when there's that I'll even go
sorry.
through again tomorrow. I'll go through again tomorrow when the session is done.
Yeah. So these are beta coefficients. You've seen these are there is a constant. This is your beta naught. Where there is beta naught, you write this amount. You understand? That's generic formula that I put. Where there is beta naught, you write that. Then
Mm-hmm.
beta 1 for capital. The x1 we said is capital. So where there is beta 1, you write that. Beta 2 that. Beta 3, beta 4, beta 5, beta 6. You got it, right?
Mm-hmm.
Maybe let me see what the question is asking. I've started explaining a lot of things before checking what the question wants. Write the results of this model in standard form. So this is the model. The standard form of this model is Y, your GDP is equal to, don't write beta naught, you have to write 2877 point what? 0.194 plus 822.77 x1. You get it, right? Plus 574 point what? 28 x2. Are you following, right?
Yes.
And da 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 da. I think you get what I mean. From here, you go to the next coefficient. Is you say x3, x4, this coefficient x5, plus the error term. We are good? Are we still
Hello?
connected?
Yes.
Are we, we are still connected? Any question?
No, for now.
You can ask a question. So interpret the results presented in a 10 marks. Interpreting the results. Let's get back to this. Interpreting the results. There are a lot of results. Key results that you should interpret are the coefficients and also the significance. Significance, we just look at this, the p-value, the sig. This one is the p-value. Remember, if the p-value is less than 0.05, what does that mean? It means that the variable is statistically significant to the model, right? The variable is statistically significant to the model, so which means it has some explanatory power. It's important, it's significant, it's useful in explaining that model. Okay. So maybe let's start from significance before we start interpreting what the changes, what's this, the coefficients. One, we can start with capital. Is capital statistically significant? Is it significant? Hmm?
Yeah.
I'm saying, is capital significant? Hello? Hello? Yeah, I'm saying, is capital significant?
Capital. No.
Yeah, so it's greater than 0.05. You've seen it, right? Then labor. Labor is what? Is less than 0.0. Yes, so it is significant. Also, seed quantity is significant, fertilizer significant, gender significant. Also, the education level there is significant. You have picked it. I think you have gotten the decision rule, right? So it means that these variables are important. We need them in explaining the output of maize. The interpretation would be, if the sign is positive, it simply means an increase in the unit of that variable increases the maize output, which is our yi, by those units. So we start with the capital. We can start with capital. So a unit increase in capital increases maize output by 822.77 units, isn't it? A unit increase in capital increases the maize output by 822.77 units.
How are you getting the 822?
It's here, it's a coefficient. You interpret the coefficients now. These coefficients, the betas. These are betas, right?
No, I didn't see the 822.
Then for labor, similarly, a unit increase in labor or an additional person employed increases maize output by 574 units. An increase in the seed quantity increases by that 154. An increase in fertilizer It increases by 2,129 units. You're following, eh? It increases output, the maize output. That's how it should be reading. Yes.
Okay.
So for gender, this one seems to be a dummy variable. Being a male increases the chance of producing output by 0.141. So it means those who are male are more likely to produce it as compared to those who are females by 0.149. You got it?
Yeah.
Then the education level, the higher the education, a year added in education increases what? Maize output, right? By those units, by 0.712. Okay. Yanga boss, mwalimu. Mm.
Go.
You are good. Then the R squared, you've seen, is 87%. So it simply means this model is able to explain about 87% of variations in the dependent variable, which is actually maize output. All right? That's what R squared means. And so you could explain the adjusted R squared because that's the one that we use. If you're given two of them, you need to use the adjusted R squared, which explains 86% of variations. Okay?
Yes.
All right. I think those are some of the key things that you should interpret here about the model.
Yeah.
Yeah, the key things. The rest of the things are less important. Does labor and capital input statistically, do labor and capital inputs significantly influence maize production? Labor and capital input, check.
Yes, you mentioned yes.
Labor and capital input, are they statistically significant? That's a
Yes,
question.
yes.
Are you sure?
No, the big one 0.85. No, capital is not because this level of significance is greater than 5 than 0.05. Then labor, this
Labor
one
is significant.
is significant because it's equal to 0.05.
Regression analysis is the data analysis technique used by economists to determine the relationship between variables for testing a hypothesis. Mention the test that is used to determine the following. Explanatory power of the regression model.
These ones I don't know.
Yes. So the explanatory power of this is used by the p-value. Use the p-value of the model. Right? You remember what I was trying to explain in question 1. Then the individual significance of the variable, which is the specification of it. This one is the adjusted R squared. All right.
Okay.
Yeah. Oh, the individual significance of, no, you can use p-values. Okay, to check the significance of individual independent variables, you use p-values.
Mm-hmm.
Okay. Then for over significance, you use the R squared. Hapa Zambeka, eh?
Mm-hmm. So p value
Explanatory
is
hmm?
explanatory power.
The p-value of the model, the entire p-value of the model. Then this one p-values of those variables, and then the adjusted R squared is for significance of the regression model.
Okay.
Okay. Kwamana, you've seen how we are not struggling. Within short time, we are done. What else is this now? An undergraduate student has collected data on price and corresponding quantity. The sample is 50. All right. Why did the student choose to do her estimation using the log-log model rather
The
than the
log.
simple yes?
So for the log or log real model,
Mhm.
this is because the is it the p value or this I don't know, but this is the concept that I understand. It's because uh, they are measured, the units are measured as a percentage, and they are specific compared to a regression model. Regression model measures units. For this one, the final answer is in percentage. I don't know if that's correct.
Oh,
Something.
interesting. Yeah, we know that this one we interpret them in percentages, but why logging?
Hmm, that's what we told. Yes, I forgotten, but that's what we did.
Mm-hmm.
Yeah, yeah,
Okay.
yeah,
So I said that because the numbers are small numbers that you are using, eh? They are less than 100. Their percentages are less than 100.
yeah.
Okay. Obtain the t ratio for the coefficient of the following estimated regression. What is the t ratio? You know how to do the t ratios. You know how to find the t. The t ratio
Yes,
is the
equal to
beta
beta
standard
over
error.
standard error. Yes.
Yeah. What is the price elasticity of demand of the good in question? Is the demand for this good elastic? So you just differentiate this with respect to x, since the good is x. So
Mm-hmm.
do the derivation with respect to that. Yeah.
Mm-hmm.
Mhm. And we find that the elasticity of this is what? Is negative. It's less than 1. Okay.
Mm-hmm.
It's just negative 0.94. Since it is less than, it's between 0 and 1, in absolute terms, of course, it means that the demand is what? Is inelastic. You get it, right? So the demand is not elastic. You understand? It is inelastic.
Mm-hmm.
Hmm. You're quiet. Are we still connected?
Mm-hmm. Yes, we are.
Okay. We are good.
Yes.
There are just 4 questions. We are ending soon. Don't worry. Hmm. Is the is the yeah is the
Have
relationship
they,
between price? Hello?
have they been had sleeping? Okay.
Or you haven't been sleeping for the longest?
Like for the past 2 days, I knew that the dates were yesterday, then they changed to today. So, yeah. You can go ahead.
Is the relationship between the price and the quantity demanded statistically significant? So you look at the p-value,
Mm.
you look at the t statistic that you're going to do. So that is what will help you to know whether the relationship is statistically significant when you divide this by that. So at 5%, if it is greater than 2.54, if it is greater than 2.5, then it is statistically significant, right? You got it?
Yes.
All right.
I'll
I
go
think
through in the
that's about question 3. Otherwise, there is nothing much. Yeah, we can even conclude with question 4. It's already done. Really, it's short. This one. Why does the regression include the error term? So to capture the variations that are not explained
yeah,
uh,
yeah,
in the model.
yeah,
You got that? Yeah. Give 2
yes.
examples of factors that are contained in the error term, like omitted variables. Omitted variables, misspecification errors. All those they are captured in the error term.
Mm-hmm.
Okay. Why is the model above called simple linear regression? Because it just has only one independent variable. Right?
Mm-hmm.
There are some very important elements of the classical that every person studying may need to understand. Explain any 5 assumptions. You can explain the 5 assumptions since you said you were doing those. Isn't it?
Yes. Say the
Mm.
assumptions are then so any five. Yeah.
Linearity, normality, homogeneity, homogeneity of the variances,
Mm-hmm.
which is heteroscedasticity, the variation, independence of the independent variables. Because if there is no independence, there will be multicollinearity, those things. And yeah,
They said the equation has to be linear. This is
linear in parameters. Mm.
when row and the column have to be signed.
I think we got 100% paper. You've seen. We're within less than 30 minutes. We're done solving it. You've seen. Now this one is where you drive. Since you learned how to solve betas, you know how to solve betas. So this will give you
And
B naught. B naught. We can
let's
find.
go back. Let's go back to percent four. B.
Mhm.
Prove the following.
Yeah.
So
Can you,
proving is a
mhm.
oh, this is summation lesson. You prove
You
it to
remember?
be
You
summation.
remember this? How to prove these betas?
Hmm. Now this other one, summation X.
This one, like, it's the same stuff. Like you set this by error term is equal to 0. So in short, it's just a reference of the question of finding the beta one and beta naught. Nothing much.
Yes,
This is beta one, beta naught. You can do those derivations. That's not a big deal to you.
yeah, no, that one, no. Then this one,
Then
no.
you can this you can it's easy. You can even use a calculator. I think I explained how to use a calculator on this. I don't know.
Mm.
You can come up with beta one and the beta two and specify the model. You can even write
Now
and
you say
interpret
that
it.
you don't have to use a calculator.
You can use a
You said
calculator.
that
No, it is allowed in econometrics to use a calculator.
you said that you have to show your way to it. Like for
Yeah, that.
example, in
Oh,
the
oh, yeah. Oh, yeah. So
section,
you can use the other approach. because it's the same stuff. For example, beta 1 is equal to the summation of xy minus the
minus
summation of x summation of
summation
y, right?
over
Divided by
summation
n
x
summation of what? X squared minus summation of x, then you square. You can do this individually. This is x. So when you want to get, for example, summation of
no
xy, you
no
multiply
this
x
one
times y.
no this one I know this one you don't even have to waste time. I know
Oh
even
yeah.
in my sleep I can answer this one.
Okay.
Yeah, this one I know. I
Then
just wanted
the exam is done. Come on.
yeah, what I really wanted, I think what I want to I'll be going through tomorrow and answering is the assumptions and interpreting and also elasticity.